First thing is about set. Okay, so last time we discussed a little bit about the set theory. And as a matter of fact, you should have learned set theory in your senior high school. So it's just a very brief review. So the first one, subset. Okay, so if every element of one set is within the other set, then we call B here in this case. B is a subset of A. Okay, B is a subset of A. An empty set, there's no element in an empty set. So let us say A intersect B. Okay, if there's no element, then we put it empty set there. The notation, okay, we know that's a phi, a Greek letter called phi. And complement of A, it is for every element that is not in A will be in complement of A. So basically, here, A, okay, plus A complement. Sometimes we use bar. Sometimes we use tilde, okay? And then it is the whole sample space. And the third one, it is intersection, right? So for every element, it is in A and in B. That should be in A and B. And union, it is A or B, okay? So this is intersection. But there's something wrong with this diagram because sometimes there is no intersection, right? Sometimes A intersect B is equal to empty set. So in that case, the gray area should be 0, okay? Should be none. There's no intersection, suppose. And this is A union B, okay? Everything in A or in B will be here, okay? And of course, if you remember, we talked about a little bit the algebraic formula, right? So we say if we want to know P, A, or B, okay, or you say A union B, then it is equal to PA plus PB and minus PA and B, right? And if we're going to make things a little bit more complicated, then we get 3, okay? So we have P, A, or B, or C. That would be equal to PA plus PB plus PC, okay, minus P, A, and B, minus P, B, and C, minus P, C, and A. And then you have to add P, A, and B, and C. So this is a very simple formula, okay? And the next one is partition set. We said, you know, for every set, for the partition set, every set, you know, it is mutually exclusive. That means intersection of any other two sets, okay, it is equal to empty set. But if you put the whole thing together, it is equal to a sample space. Okay, so the diagram can show you very clearly. So here, B1, B2, B1, B3, B1, B4, B1, B5, the intersection is empty set. Okay, but you put the whole thing together, what is it? It's equal to B, the whole sample space there. Okay? Okay, and we now introduce the properties of probability. So for every event, okay, for every event, the probability is greater than or equal to 0 and less than or equal to 1. And if you put all of the events together, the probability should be equal to 1. So that is the formula there and then the formula there, okay? And so we talk about the, you know, the theory behind probability. The first one, classical, the second one, objective. You know, classical means, so let us say we cast a coin. There is the upside, there's a downside. The upside we call head, the downside we call tail. So head and tail. Because there are only two possibilities, so what should be the probability for each one? It is 0.5, 1/2, okay? But sometimes, you know, you may not believe it. Then what you're going to do? You're going to do an experiment, okay, to test whether that is true or not. So in this case, what you need to do is to cast coin many times. And then you're going to find out, say, suppose you cast coin 1,000 times, then you find out that, okay, 500 times it's going to be head and 500 times it's going to be tail. Of course, it will not be that perfect, but the more the more experiments you do, the closer to 1/2. Okay, and of course there is another kind of probability we call subjective probability. Okay, so if you are the meteorologist, so you're going to forecast the weather and say, when typhoon going to hit Taiwan. So in this case, we can be sure no typhoon going to hit Taiwan because the weather is so nice, right? But then sometimes if you look at the diagram, a lot of diagrams like radar, okay, you look at where are the clouds, okay, and where are the high pressure, where are the low pressure. So sometimes the weather forecaster, he can tell you, what's the probability it's going to rain, or what's the probability a typhoon going to hit Taiwan or not. Is that exactly what's going on there? Not necessarily. Sometimes he had some subjective judgment there, okay, according to his judgment. So this is what we call subjective probability. So every day, if you look at the weather report, they're going to tell you what's the probability that Kaohsiung going to rain. 20%, 10%, okay? And sometimes in Taipei, the weather pattern is kind of different, so the probability of raining is higher. That is subjective. But of course, it's not purely based on his judgment, because he also has some diagrams, some charts, some statistics about weather, about humidity, about the pressure, all these things to help him to make a correct prediction. Okay, so that's about it. Let's move on. So what is conditional probability? Okay, so let's get the formula first. So P of A given B. This is what we call conditional probability. What does this mean? We want to know probability of A. Okay, we want to know probability of event A, but given B happen. Okay, given B happen. So what is the first thing? The first thing is event B happens. Okay, event B happens. Okay. So event B already happens, right? This already occurred. But we want to know when this occurred, what's the probability this going to occur, right? So what does that mean? When B occurs and also A has to occur. So it is A and B. Okay? So given B already happened, right? What's the probability that A will happen? So that means A and B has to happen together. Okay? So basically this is the formula. And here, let me think about it. There is something wrong here. So forget about this line. I have to revise it the next time. And there is another new concept. This new concept is independent. So we say if P A times PB is equal to P A and B. This is what we call independent. Okay, independent. What does independent really mean? Of course, in terms of formula, it is right there. Generally, what that means is whether A will occur or not, okay, does not affect the probability of B. Okay, so let me repeat this again. When we say A and B, these two events, they are independent. We say when whether A will happen or not does not affect the probability of B. Okay, basically A and B, there's nothing there. Okay, but in terms of determine whether two events are independent or not, we have to use that formula instead of any kind of intuition. Okay, it is based on this formula. Okay, and then we're going to get several things here. So if A and B are mutually exclusive, then A and B must be dependent. Dependent means they are not independent, okay? So let me use this. Okay, so if A and B, okay, if A and B are mutually exclusive, then A and B are not independent. Okay, so what does that mean? That means this one is not does not hold. Okay, so if A and B are mutually exclusive, then we know A and B must be equal to empty set, right? And so P A and B must be equal to what? 0, right? So if A and B are mutually exclusive, what does that mean? That means this one is equal to 0, okay? If they are equal to 0, what's the chance that PA times PB will be equal to 0? Very small, right? Unless, okay, unless A or B is equal to empty set, but that, does not necessarily hold. So if A and B are mutually exclusive, then they are not, okay, they are not independent. So that means they are dependent, okay? So let us move on. Okay, here. So you can see if A and B are independent, then A and B are not mutually exclusive, because that equation gonna hold, okay? That equation gonna hold. So PA times PB must be equal to PA and B if A and B are independent. So what does that mean? That means the intersection of A and B will not be equal to empty set. If that is the case, then they are not mutually exclusive. Okay, so if A and B are independent, that means that equation will hold, and so they are not mutually exclusive. Okay, if they are not mutually exclusive, okay, look at the third line. Okay, look at the third line. If they are not mutually exclusive, basically that just means the intersection is not equal to empty set. Okay, that basically just means the intersection is not equal to empty set. So that means that equation will not necessarily hold. So they are not necessarily independent. But, okay, the fifth line, if A and B are mutually exclusive, that means the intersection is equal to empty set, right? So that means they are not independent. Okay, they are not independent. Okay, any questions so far? Okay, so a little bit more complicated, but it should be, if you spend a few minutes thinking about it, you should be able to grasp hold of it. Okay. Okay, this is one of the questions. Okay, so we have PA is equal to 0.6 and PB is equal to also 0.6. And here we have a conditional probability. Conditional probability PB given A is equal to 0.3. So the first question, please find P, A, and B. And then the second question, are A and B independent? Okay? So because here we have PA is equal to 0.6, okay? And PB is also equal to 0.6. There's something wrong with the notation. Let me check it. As a matter of fact, you should do it in a different way. Okay, let me put down here. I'm working on this PowerPoint in a hurry, so that's the reason sometimes there are some mistakes there. Okay, so we have PA is equal to 0.6, right? And PB is also equal to 0.6. And PB given A is equal to what? 0.3, right? Okay, the first question is P, okay, A and B, right? So this is the first question, okay? The second question, A, B, independent? Okay, so this is what we're going to find out, right? P, A, and B. So where to find A and B? So here you only have information about A, and here you have information about B. So you have no information about A and B. But here you know, this is conditional probability, right? So P, B given A. Okay, can anyone tell me what is this equal to? So the gentleman in brown t-shirt. I mean, not light brown. Okay, that's you. So what is this equal to? P, B given A. What is here? So you know A already happened, right? So what is down here? What should be down here? The next one close to a window. What should be here? The gentleman in black t-shirt. It should be P of, it should be P of A, right? So A already happened, right? And what should be up here? P, A already happened, right? Given A happened, what would you want to know? You want to know what's the probability B going to happen, right? So what does that mean? A and B happen, right? Okay, so here is the information we can find out what is equal to P, A, and B, right? What is this equal to? According to the question, is 0.3. Okay? What about PA? How much is here? The question tells us it is equal to 0.6, right? So that means PA and B is equal to 0.3 times 0.6. So what is that equal to? That is equal to 0.18, right? Any questions so far? Any questions? So in this case, are A and B independent? If A and B, if they are independent, what is that going to equal to? Is A and B here? So suppose A and B, okay, suppose A and B, they are independent. What should be the probability of P, A, and B? So this gentleman, if A and B, they are independent, what should be the probability of P, A, and B? What's the definition? If A and B are independent, then PA times PB must be equal to PA and B, right? So if that is the case, PA and B should be equal to 0.36. And what is now equal to? 0.18. So are A and B independent? No, right? Is that clear? Confused? Okay, later on we're going to do more examples. So let us get to this chart first, okay? I need some of you, I need you to help me with the numbers, okay? So that is, okay, I think there's something wrong. Anyway, so we are looking at a high school, okay? We are looking at a high school. So of course for students, they are female and male, right? Okay, female and male. And also for high school, we have the first year we call freshman. Okay, the first year we call freshman. The second year we call junior. And the third year we call senior. What about college? The first year we call freshman. The second year we call sophomore. The third year junior. The fourth year senior. Okay, anyway, let us look at the table there, and we're going to put down here on the blackboard. Okay, so we have freshman. We use fresh. Okay, anyway, put the whole thing down. And then we have junior, right? And then we have senior. And we have male and female. Can anyone tell me the number here? 200? 2,000? 200, right? Oh gosh. So that's 2,000? 2,000? And what's here? 7,000? 3,000? Okay. And then 1,500? 3,000? 1,500? Okay, what's here? 1,500? Okay. Okay. So basically this is the table, right? Okay, and then what we have here. So here the number is 4,000. Okay, and here we have 4,500. Here we have 1,500. Okay, and here we have 6,000. Here we have 4,000. Okay, let me ask you this question quickly. The girl, the lady in gray t-shirt. So what's the probability if you choose from all these people, right? These students. What's the probability you're going to get a female? What is the probability you're going to get a female? We put all these people together, right? You're going to get one from there. What's the probability you're going to get a female? It should be equal to, how many people do we have? We have 10,000, right? And what's the probability you will get a get a person, and this one is a girl? What's the probability? Should be that gentleman. What should be the probability? 0.4, right? Because you have 10,000 people and 4,000 female, right? So the probability is equal to 0.4. Okay. The same thing. What's the probability you're going to get a male? 0.6. Okay. Now, what's the probability you're going to get a freshman? Okay, freshman. The gentleman with white t-shirt. What's the probability you're going to get a freshman? 20%? A freshman. What's your answer, please? 0.4, because you have 2,000 freshman male and 2,000 freshman female, right? So it should be 0.4, okay? Let me try one more. The gentleman in blue t-shirt, blue shirt. So what's the probability you're going to get a senior? What's the probability you're going to get a senior? 0.15, right? Okay, 0.15. Okay, so basically these are all fine. There's nothing about conditional probability. Okay, so let us try to answer all these questions. So suppose, and now let us revise this table, okay, just like the second one, okay? So the first one is about frequency, and we turn that into relative frequency. So in this case, it is close to probability, okay? So here it's going to be 0.2, right? 0.2, 0.2, 0.4, 0.45, 0.151. Okay, so we just basically do the same thing, turn the frequency into relative frequency. And in this case, as a matter of fact, it corresponds to the probability. Okay, now I want to know. Suppose I already choose one person, and I know this person is a male. Okay, I choose one person from this group, and I already know this person is a male. And I want to know what's the probability that it is a freshman. Okay, can anyone tell me that? So the girl in pink shirt, in pink coat, sorry. So what's the probability? I already choose one person, and I know this person is a male. So can you tell me what's the probability he's gonna be a freshman? So in this case, you have to transform the words into a formula, right? So here, given this person is a male, what is the probability that it's going to be a freshman, right? So what is this equal to? What's down here? P of M, right? So you need to know the probability of this person being a male. And what is up here? P freshman and male, right? Okay. So what is this equal to? What's that? 0.6, right? And what is up here? Freshman and male. So here it is a freshman, right? And then here it is a male, right? So what is here? This is freshman and male, okay? So what's the probability? 1/3. So if you want to know whether this person is a male and a freshman, okay, suppose you have no idea and you want to choose a person randomly, okay, what is the probability that this person is going to be a male and freshman? The probability is equal to 0.2, right? But suppose now you know some more information, and this information is, we already know this person is a male. Suppose you already know this person is male, and what's the probability that he is a freshman? So supposedly, this information, this person is male, should give you more information, should give you higher probability to know what's going on in terms of whether he is a freshman or not, right? So suppose you don't have any information, the probability that you get a freshman and male is equal to 0.2. Now you have some more information. This person is a male, right? So what's the probability you get? You already know this person is male, and what's the probability this is going to be a freshman? The probability indeed is higher, right? 1/3. 1/3 is equal to 0.3333, right? Okay. Okay, let us get some more exercises here. After this, we're going to take a little break, okay? Let us try one more. Okay. I already know this person is a senior, okay? I already know this person is a senior. What is the probability that this person is going to be a female, okay? So let me try. That lady, okay? So, right. So what's the probability, okay? You already know this person is a senior. What's the probability that it's a female? So in this case, the same thing, right? Follow the formula, okay? What should be down here? 0.0. Are you sure? Okay, so it should be probability of senior, right? Okay, and that is equal to 0.15. What is up here? It should be probability female and senior, right? So what is the probability? It's a senior and also is a female, right? So 0.05. So what is that equal to? The same thing, 1/3, right? Okay, so let us take a break here. So let us say we already choose one. Okay, so let me put it down in terms of words. Okay, and you are going to translate those words into a formula. Okay, so let us say we already select so we already chosen a female, so, and what is the probability that she is a junior? Okay, so the question is, well, we already chosen a person from this group and we know that she is a female, and what's the probability that she is a junior? Okay, so we get the girl in the first row. So what is the can you help me to get this? So first, what is the formula here in terms of conditional probability? So we already chosen a female. What is the probability that she is a junior? Okay, so what should be here? What should be here? We already know she is a female, right? And we want to know whether she is a junior. What's the probability? The girl next to her. Female, right? Okay, female. And what should be here? Junior, okay? So then what is this equal to? Down here, okay, down here it should be probability of female, right? And up here it should be junior, okay? And, or we put it here, and female, right? So what is the probability? Probability of female is equal to 0.4, right? And female and junior. So female and junior. So it is 0.15, okay? So that should be 3/8, okay? 3/8. Or we call 3/8, okay? 3/8. Questions? Questions? Okay, let us get down to the next. So we already talked about this, right? PA or B is equal to PA plus PB minus PA and B. PA or BOC is equal to PA plus PB plus PC minus PA and B minus PB and C minus PA and C plus PB and B and C. Basically, this is a very simple formula, but let me remind you, when we get to the exam, okay, when we get to the exam, you should be able to do this. Okay, so let's say this is A, this is B, this is C, right? So where is A and B? A and B is here, right? B and C is here. and A and C is here. And this part is B, A, and B, and C. Okay? So if you can fill in all these numbers, you should be fine. Okay? We will do one example on this, okay, later. Okay, the next one. It is the Bayes theorem, okay? Bayes theorem. So it is very simple. We have P Bj given A, right? So we want to figure out what is the probability of Bj given A happen. But the point is, Bj, it is a partition set. So remember what is a partition set? A partition set can be divided into several subsets. And for those subsets, they are mutually exclusive. Remember that? Okay? So we have here, in this case, actually, what should that be? That should be PA, okay? Right? Because A already happened. So given A happens, what is the probability Bj happens? So that means P, Bj, and A. Okay? So what is special about Bayes' theorem is this. Okay, so we have. So let us say it is here. 1, 2, 3, 4. So we have B1, B2, B3, B4. And what is A? A has intersection with all this. Okay? So this is A. So if you want to figure out A, you have to figure out 4 parts. The first part is A intersect B1. Okay, the first part, A intersect B1. The second part, A intersect B2. And the third part, A intersect B3. And then A intersect B4. Okay? So how are you going to get this? The numerator is still the same. P, B, J, and A. Okay? So as a matter of fact here, you want to know what is this? It should be, okay, P, B1 intersect A, and plus P, B2 intersect A, and plus P, B3 intersect A, and plus B4 intersect A. Okay? Any questions so far? Because B, okay, it is a partition set, and suppose B looks like this. Okay, we have B1, B2, B3, B4, and A is like this. So the way you're going to figure out A, of course, if the question gives you information about A, that is fine. Okay, you don't have to do anything. But suppose you don't have any information about A, what you're going to do? You have to add B1 intersect A, B2 intersect A, B3 intersects A, and B4 intersects A, right? You have 4 parts here. Okay. How to get this? Okay. So here, P, Bj, the same thing, right? And how to get this? As a matter of fact, it should be equal to P, B1 times P, B1, okay, given A and B1, right? Okay. And also P, B2, okay, times P, B2, BA intersect B2. So we can do this, etc., right? On and on and on. And so what is this equal to? So P, Bj intersect A, and then down here you have summation P, Bj times P, A given Bj. And of course, J is equal to 1 to 4. So that's the reason we have formula here, right? So you want to know what's the probability of Bj given A happens, right? So if you put it down there, it's going to be like this, okay? The first equation there, okay? And then the way to simplify it, it is like this, okay? So the numerator does not change. The numerator is all the same. But what about the denominator? The denominator down here, you can use conditional probability. Okay, you can use conditional probability, trying to figure that out. Okay, so basically this is the Bayes theorem. Sounds like a little bit more difficult, but basically that is just an application of the conditional probability. Okay? Questions? Mr. Zheng, question? No, Mr. Ren, question? Okay, so basically it's like this. But now let us look at one example so that you know how to apply this formula. Okay, so we have the probability of getting freshman is equal to 0.15, junior 0.4, senior 0.45. And we have another information, that is, if it is a freshman, already know this person is a freshman, and then he is a female, the probability is equal to 0.04. And given that you already chosen a person, this person is a junior, and then the probability is going to be a female, that is equal to 0.065. And another one, given this person is senior, the probability that it's going to be a female, that is equal to 0.04. So that's all the information you know, okay? And now, suppose you have chosen a female. What is the probability that this female is a freshman? Okay? Okay. Okay, so which person I'm going to choose? The gentleman down there. Okay? So can you tell me how to translate the words into a formula? So we are going to, suppose you selected a female, right? You already get a female. What is the probability that this female is a freshman? So can you tell me how to put down in terms of a conditional probability here? P, okay, what should be here? So you will select a female, and what is the probability that this female is a freshman? What is here? What should be here? The girl in front. So that's the girl behind the girl with a pink coat. Your turn, right. So what should be here? What should be here? What should be there? So you select a female. What is the probability that this female is a freshman? So the gentleman next to her. What should be here? Female, right? And what should be here? Freshman. Okay? So in terms of formula, it should be P of female, and then up here it should be P freshman, right? And female. Okay? Okay. So then we have to try to get the answer from here, right? So what's the probability of female? Okay, sorry, do we have any information about female? Nothing here, right? But what about female and freshman? Okay, so we have freshman, junior, senior, freshman, and female here, right? So sounds like we can find something here. Okay, so we have P, F, and freshman, right? What is this equal to? What is this equal to? 0.04, right? 0.04. And this one is equal to, okay, here, P freshman, right? And here, it is equal to PF and fresh, right? What is this equal to? Probability of freshman. 0.15, right? 0.15. Okay, so 0.04 times 0.15 is equal to probability of female and freshman, right? So what should be here? It should be 0.04 times 0.15, right? So up to this point, any questions? So in this case, the first thing is translate the words into formula, right? So select a female, and what is the probability that the female is a freshman? So given this person is a female, what is the probability that it's going to be a freshman, right? And then turn that into formula. The denominator should be P of female. The numerator should be P freshman and female. But of course here we don't have any information about P of freshman and female. But here we know the probability of a person being freshman is equal to 0.15, right? And then given this person is a freshman, okay, what's the probability is going to be a female? It is equal to 0.04. And here, okay, so we can get this part up here. But still, we don't have any information about what? We don't have any information about female. But for each class, okay, for the freshman, for the junior, for the senior class, for each class there is there's a portion of female, right? So the same thing. If you can get junior and female, senior and female, then you can get all of the female, right? Okay, let me repeat this again. Because for this group, they can be divided into male and female, right? Of course, they are female in freshman class, in junior, in senior, right? So if you can get the female in freshman, the female in junior, the female in senior, then you can get all of the female, right? Okay, so basically that is the same thing there. So 0.04 times 0.15, this part is the female in freshman, right? This part is the the female in freshman. What about the female in junior? The female in junior should be equal to 0.4 times 0.065, right? So 0.4 times 0.065, okay? So this is the female in freshman. This is the female in junior. And what about the next one? 0.45 times 0.04. 0.45 times 0.04. So this is the female in freshman. This is the female in junior. This is the female in senior. So then what you get? You get all of the female, right? All of the female. Okay, so basically this is the application of Bayes' theorem. You just apply it, okay? Supposedly not that difficult. you just apply the conditional probability, okay, the concept of conditional probability, then you should be able to get it. Okay, so let us get to the answer there, right? So you have 0. Here it is, you are trying to get the female, okay, and then the freshman there, okay? And so basically, let us try to get the answer, okay? Let us try to get the answer here. So here it should be 0.006, right? Anyway, I think if you have calculator, you should be able to get it. So unless you cannot get the answer, otherwise, for the moment we're going to continue right on to random variable. Okay, let us continue. If you get a formula, you should be able to get it, and it is very important here, right? I already said this. If in the midterm or any kind of exam, if you got your formula right, but you get your number wrong, you still get credit, okay, you still get points. But suppose you get your formula wrong, your answer right, you get 0 points there, okay? So this is very important here. Let us move on to random variable. So random variables, actually, it is functions, okay? Sometimes we use function to represent, say, upside of coin or downside of a coin. That is easier, okay? So sometimes we need to quantify the elements we are studying. So that is easier to get a hold of it, okay? The next one, we have two types of random variables. The first one, discrete, okay? Discrete basically means integer, right? Continuous, it is real number, or sometimes you can have fractions, you have decimal points, okay? So the first one, like number of people, number of cars, and the second one, continuous, like weight, like height, like income, okay? Okay, and the probability, properties of probability, the same thing. For any event, the probability is greater than or equal to 0, less than or equal to 1. And for the whole thing, okay, for the whole sample space, the probability should be equal to 1. Okay, now we are going to do this. Cast a coin twice, okay, cast a coin twice, and X is the number of the heads showing up, okay? X is the number of heads showing up. So in this case, what are the probabilities there? There are 4 possibilities, okay? So X, it is the number of heads, okay? So for X, let us look at this random experiment first. You cast a coin twice, okay? You cast a coin twice. So what can you get? You get H, right? 2 heads, head and tail, tail and head, and tail, right? So in terms of distribution, okay, now we are talking about probability distribution. So X and PX, okay? What is this equal to? Because you have 2 heads, so X is the number of heads, right? So what should be here? It is equal to 2, right? Because you have 2 heads. Here you have 1 head, so it is equal to 1. 1 head equal to 1. 0 head equal to 0. And what's the probability here? It is equal to 1/4. Okay, 1/4 is equal to 1/4, right? The same thing, 1/4, 1/4, 1/4. But of course, there's something wrong here. So there's another way to do the table here. So actually we can have X equal to 0, 1, and 2, okay? X is equal to 0, 1, and 2. And what about PX? PX is equal to 0, it is equal to 1/4, okay? 1, you have 1/4 and 1/4, so that is 1/2, okay? And what about here? 1 false. Okay, any question so far? Okay, now we're going to get to calculate, okay, we're going to calculate, so then this table, okay, this table is we call the probability distribution of x. Okay, let me repeat this again. What is this table? This table is the probability distribution of x. And what is x? X is when you cast a coin twice, so you do an experiment, and this experiment is to cast a coin twice. And x is the number of heads. Then this is the probability distribution of x. Okay. And now we are trying to get this number. Okay. What is the mean? What is the mean? And what is the variance of x? Okay? So in this case, because we are talking about probability and we are talking about random variables, so here what we call, it is called expectation. Okay? So expectation, in terms of notation, we have expectation of x. Okay? Expectation of x. And what is expectation of x equal to? It is equal to summation xi times pxi. Okay? Summation of xi times pxi. Remember, the first time we talk about data, we have group data, right? For group data, we times that by relative frequency, right? Relative frequency. And basically, we replace relative frequency with what? With probability. Okay, we replace relative frequency with probability. So what is that equal to? How to calculate it? So what is the first xi? The first xi is equal to what? 0, right? Times 1 false. What about the second xi? It is equal to 1 times 1 half, right? The third x is equal to 2. So 2 times 1 false. So 0 plus 1 half plus 1 half. It is equal to 1. Okay? So here you can expect the average number of heads you're going to expect. Suppose you cast a coin twice. What's the number of heads you're going to expect? 1. Okay, 1. But this does not mean, you know, this is the number going to show up, or this is going to be the number of heads going to show up. Sometimes it is different. Okay, let me try one more example. Okay, this example going to be cast a dice. Anyway, question here? Any questions here? Okay, so let's talk about variance. What about variance? Variance is equal to Vx. Okay? Variance is equal to Vx. That is equal to summation xi minus mu x squared times pxi. Okay? Summation xi minus mu x squared times pxi. Of course, there is another way to simplify it. Okay? So what is that going to equal to? Going to equal to summation xi squared times pxi minus mu x squared. Okay? Okay. But sorry, does the podium block your view? No, okay. The same thing, there is a way to simplify this formula, and it is here. Okay? Okay, so let us do this again. We are going to get Vx. Okay? We are going to get Vx. Vx is equal to, let us use this formula. Okay? Let us use this formula. So we already know mu x, that is expectation of x, is equal to 1, right? So you have xi, the first xi is equal to 0. So 0 minus 1 square times 1 false, right? And plus, the second xi is equal to 1. 1 minus 1 square times 1/2. Okay? And the third xi is equal to 2. So 2 minus 1 square times 1/4. Okay, so you have 1/4 plus 0 plus 1/4, so that is equal to 1/2. Okay, so this is the expectation and variance of a random variable, and this kind of random variable is a discrete type. Okay, this is a discrete type. Any questions? Let us take a break.